Look at your hand for a second.
Yeah, just hold it up and look at it.
Right, like clench your fist. You feel the tension in your muscles. You feel the temperature of the room against your skin.
You possess this totally inescapable intuitive sense that you are a single unified entity.
Exactly. You are an observer, right? You're occupying one specific vantage point in this shared, stable universe with the rest of us.
Well, according to one of the most radical interpretations of quantum mechanics, that intuitive sense is a profound illusion.
A total illusion. I mean, the idea that you actually exist as a distinct, singular entity is just mathematically false under this view.
Well, what you call you is, it's really nothing more than a temporary, vibrating network of private agreements made by billions of disconnected particles.
And that unified reality you think you're looking at, it is mathematically hanging by a thread.
A very thin thread.
So, welcome to this deep dive. Our mission today is to unpack a highly provocative 2024 paper by the physicist and philosopher Emily Adlam.
It's titled A Combination Problem for Relational Quantum Mechanics.
And our goal for you listening today is to provide a really rigorous, expert-level commentary on a paradox that basically threatens to break quantum mechanics wide open.
Right, the question of how the microscopic, fundamentally isolated building blocks of reality scale up to create the cohesive macro world you actually experience.
Because to really appreciate the severity of the problem Adlam is tackling, we have to recognize that she is bridging two disciplines that have, well, historically viewed each other with deep suspicion.
Oh, absolutely. I mean, to solve what might be the deepest architectural flaw in relational quantum mechanics, physicists are essentially having to borrow a massive structural headache from the philosophy of mind.
Specifically from panpsychism, right?
Yeah, exactly. They're looking at how the mathematical architecture of quantum physics maps directly onto theories of fundamental consciousness.
And this is the tension we're going to explore with you. We're taking a philosophical framework about the nature of mind and applying its brutal structural logic to the raw mathematics of quantum physics.
But before we dive into the philosophical parallels, we really need to set the stage purely in the realm of physics.
Right. We need to define the exact mechanics of relational quantum mechanics, or RQM, which Carlo Rovelli pioneered back in 1996.
Yeah, and for those of you listening who already follow quantum foundations, you know all about the traditional measurement problem.
Right. The Copenhagen interpretation leaves us with this sort of embarrassing gap where unitary evolution just suddenly stops.
Exactly. The wave function, quote-unquote, collapses the moment a macroscopic measuring device, or a human, interacts with it.
Which treats the macro world as fundamentally distinct from the micro world. It's magic.
It is magic.
Yeah.
And RQM attempts to bypass this entirely by declaring that quantum states are just not absolute. They simply do not exist objectively for the entire universe to agree upon.
Instead, every quantum state and every outcome of a measurement is strictly relative to an observer.
And this is crucial.
Yeah.
We have to be extremely careful with that word, observer.
Oh, yeah. The term carries centuries of epistemological baggage, doesn't it?
Tons of it. In standard parlance, an observer implies cognition, intentionality, maybe a complex laboratory setup.
But RQM strips all of that away.
Completely away. In RQM, any physical system whatsoever can act as an observer.
So a single electron bouncing off a stray photon in the interstellar void is an observation.
Yes. When two arbitrary quantum systems interact, they establish what's called a relative fact between them.
Meaning reality in this framework isn't a single objective canvas.
Right. It's built out of these microscopic, entirely private handshakes between interacting quantum systems.
Okay, let's unpack this immediately, because this is where the foundational crack really appears.
The combination problem.
Exactly. If every single fundamental particle in the universe is its own observer, constantly generating its own completely relative reality through random interactions, how do we ever get a shared reality?
It's a massive issue.
Like if I look at a macroscopic object, say a brick wall, the retinas in my eyes, my optic nerves, those are composed of billions of distinct quantum particles.
And under RQM's rules, that's billions of distinct observers.
Right. So how do billions of independent microscopic realities seamlessly combine to form the single cohesive conclusion that the wall is red and solid?
That is the combination problem. And as Adlam outlines, it is not just a semantic issue. It's a fatal threat to the theory's viability.
Because if RQM can't mathematically prove how micro-observers sum together to form a macro-observer, the whole theory collapses, right?
It collapses into a kind of quantum solipsism, yeah, a state where nothing larger than an elementary particle truly exists.
So as the three of us, you listening, and the two of us here navigate this, we're going to interrogate whether a radical upgrade to RQM is the only mathematically sound way to rescue reality.
To stop it from dissolving into a cloud of disconnected microeffects.
Exactly. But to understand the proposed rescue, we have to look under the hood. We need to define what Adlam calls the thin observer.
And we have to do it with absolute mathematical precision.
So let's look at the actual mechanism of interaction. In standard unitary quantum mechanics, taking an idealized external perspective, when system X and system Y interact, they become entangled.
Right, and we can represent this pure state, mathematically, using the Schmidt decomposition.
And the Schmidt decomposition is non-negotiable here, isn't it?
Oh, completely non-negotiable. It is the mathematical engine of the relative fact.
Explain how that works for us.
Well, when we write the entangled state of a bipartite system in Schmidt form, we are finding a highly specific set of orthonormal bases, one for system X and one for system Y,
Okay.
such that the state can be expressed purely as a sum of paired tensor products.
Wait, I want to pause on the mechanics of that, because the structural implication there is massive.
It really is.
By expressing it as a single sum of product states, the Schmidt decomposition basically mathematically forces the messy cross terms to vanish.
Exactly. You don't have a state where X is, say, spin up, while Y is somehow in a superposition of spin up and spin down.
It neatly pairs a specific state of X with a specific state of Y.
Right. And that elimination of cross terms is exactly what allows RQM to postulate a definite relative reality.
Because there's no ambiguity left between them.
Precisely. RQM stipulates that the physical interaction, which we describe externally with this Schmidt form, actually realizes a relative fact internally.
So from the perspective of system X, system Y now possesses a specific definite value.
And conversely, from the perspective of system Y, system X possesses a specific value.
Now, the specific values realized are, of course, probabilistic, governed by the Born rule, right?
Yes, but the key is that a definite event has occurred. The superposition is broken for those two systems relative to each other.
Even while the composite system XY remains in a superposition relative to some external observer, W.
Right, W still sees X and Y as entangled, but X and Y see definite facts about each other. It's a relational hierarchy.
Let's push on this thin observer concept a bit more. When an isolated hydrogen atom in a nebula absorbs a photon, establishing a relative fact, we are saying that hydrogen atom is an observer.
Yes, it is holding a fact about the photon.
So we have to violently strip away our human bias here. We aren't talking about the atom recording data or possessing memory in a thermodynamic sense.
No, not at all. It is purely a structural relation.
Okay, so establishing this minimal physical definition of observation leads us to a vital schism in the literature, right?
Yes, Adlam highlights this extensively. The exact nature of these structural relations dictates whether RQM survives the combination problem or not.
So we need to clearly distinguish between two very different flavors of RQM. The first is what we'll call orthodox RQM.
Which adheres strictly to Ravelli's original 1996 formulation.
And orthodox RQM is brutally uncompromising when it comes to isolation, isn't it?
Brutally so. In orthodox RQM, observers are hermetically sealed off from one another.
Like perfectly isolated bubbles.
Exactly. A fact is only relative to one specific observer. It's considered physically and mathematically meaningless to compare events relative to different systems.
Unless you do so relative to a third system, right?
Right.
So if I measure an electron spin and get spin up, that is a fact relative to me.
Yeah. If you, standing in the exact same room, measure the exact same electron, you might get spin down relative to you.
And in orthodox RQM, there is no fundamental contradiction there. Because our realities are isolated, we cannot physically compare notes.
Because to say, hey, you and I agree on the spin, implies that there is some overarching absolute fact hovering above us, dictating that our facts match.
And orthodox RQM explicitly forbids absolute God's eye view facts.
It forbids them entirely to preserve locality and avoid the ever many worlds branching.
Yeah, but this extreme isolation creates a severe epistemic crisis.
I mean, I would think so.
If macroscopic observers cannot actually share information, the entire foundational practice of science becomes theoretically impossible.
Because science relies on different researchers agreeing on empirical data.
Exactly. It's an interpretation of physics that functionally outlaws the scientific method.
Wow. Okay, so recognizing this disaster, Adlam and Ravelli recently proposed a significant structural upgrade to the theory. This is the second flavor. RQM combined with cross-perspective links, or RQM plus CPL.
Cross-perspective links. So instead of hermetically sealed bubbles, we are introducing a bridge.
A bridge for information, yes.
But how exactly does this bridge function mathematically without violating the core tenet of relativity?
It's a very delicate theoretical maneuver. The CPL postulate states that if observer A interacts with a system and establishes a relative fact D,
Oh, okay.
and then observer B subsequently interacts with observer A, specifically measuring the variables where A stored the information about the initial system,
Right.
then observer B will definitively obtain a matching result.
Wait, I need to challenge the mechanics of that. If B is measuring A, isn't B just establishing a relative fact about A?
Yes.
How does that give B access to A's relative fact about the original system?
That is the crux of the CPL postulate. It mathematically forces consistency across perspectives, provided a very strict condition is met.
Which is?
Observer B must measure observer A in the exact same basis that the original relative fact was established in.
Ah, so if A measures the z-spin of an electron, B must measure the physical equivalent of A's memory of the z-spin.
Exactly. If B does that, the CPL postulate acts as a localized bridge, allowing the information to be shared.
So B now possesses a relative fact that perfectly matches A's relative fact.
Yes. Information can propagate.
It seems like a minor, almost begrudging mathematical concession just to save the practice of science.
It might seem minor, but as Adlam demonstrates, this specific distinction, isolated bubbles versus information sharing, is the whole game.
It's the absolute life or death deciding factor for solving the combination problem.
The entire architecture of macroscopic reality rests on whether information can cross those boundaries.
Okay, so before we look at how CPL solves the physics problem, we really need to address the elephant in the room.
The panpsychism parallel.
Yes. Why is a physics paper heavily utilizing the philosophy of panpsychism?
To understand the deep structure of the combination problem in quantum mechanics, we have to look at its exact mirror image in the philosophy of mind.
So let's draw that parallel for everyone listening. Panpsychism is the philosophical stance that phenomenal consciousness subjective experience is a fundamental feature of the physical world.
Right. It posits that every single physical system, down to quarks and electrons, possesses some rudimentary form of inner experience.
And the panpsychist combination problem, famously formalized by William James and later David Chalmers, asks a deceptively simple question.
How do billions of discrete, microscopic flashes of consciousness somehow meld together to form the unified macro-mind that you and I experience?
And Adlam's paper points out that RQM faces an identical architectural hurdle.
Identical. RQN's combination problem asks how billions of micro-observers, each holding private relative facts, combine to create a macroscopic observer who experiences a classical reality.
The underlying geometry of the problem is exactly the same.
Because the foundational motivation of both theories is exactly the same. They both have a desperate need to eliminate anthropocentrism.
Right, they both flat out refuse to treat human beings as magic.
Precisely. They refuse to treat macroscopic sentient beings as a fundamental, unanalyzable law of the universe.
Which, in physics, is the core of the measurement problem.
Exactly. For decades, the orthodox Copenhagen approach essentially treated the macroscopic measuring device, or the human, as a primitive, undefined entity.
An entity that somehow existed outside the laws of quantum mechanics.
Right. The wave function obeys unitary evolution right up until a human looks at it, and then it mysteriously collapses.
Which is catastrophic for a fundamental theory of nature. I mean, where in the Schrödinger equation does it specify the biological definition of a human?
It doesn't. And if a human is just an aggregate of quantum particles, why should the aggregate possess the magical ability to force collapse when the individual particles don't?
Right. This is what led to the famous Wigner's friend paradox. It highlights the absurdity of drawing an arbitrary line between the observer and the observed.
And this leads to what Adlam identifies as the central mandate of relational quantum mechanics.
The central mandate.
Yes. It's the strict requirement to formulate a complete picture of physical reality without treating sentient beings as an ontologically special category.
If your theory has to introduce a new law of physics that only activates when a human walks into the lab, it has failed the central mandate.
The macro must emerge organically from the micro.
But I have to point out the extreme irony here. To make humans less special, panpsychism decides to give the magical property of consciousness to absolutely everything.
Even rocks and dust, yeah.
And RQM, to avoid making human observers special, gives the profound status of observer to absolutely every particle in the universe.
It's a drastic move.
It feels like we are just diluting the magic rather than explaining it. Is Adlam suggesting that RQM is essentially just panpsychism hiding behind tensor calculus?
It is very easy to conflate the two, but Adlam establishes a rigid, impenetrable boundary here, heavily drawing on Ravelli's own constraints.
Okay, so what's the boundary?
RQM is emphatically not panpsychism. There is nothing mental, phenomenal, or psychic occurring in RQM's relative facts.
So there is no what it is like to be an electron in a Schmidt decomposition.
Exactly. In the philosophy of mind, the combination problem is actually trifurcated into three problems.
Okay, lay them out.
There is the subject combination problem. How do many minds become one mind? The structure combination problem. How does micro experience map to macro experience?
Right.
And crucially, the quality combination problem. The quality problem asks how the raw feeling of experiencing red combines with the raw feeling of smelling coffee.
The qualia.
Yes, but RQM completely bypasses the quality problem. There are absolutely no qualia in quantum mechanics.
We don't have to deduce a mathematical formalism for combining feelings. We are strictly dealing with physical structural relations.
Correct.
Well, that is a massive relief because combining qualia seems mathematically impossible.
It's certainly a headache.
But just because we're only combining physical structures doesn't mean the math suddenly becomes easy.
No, not at all.
Because when we look at the structural reality of the microworld, we run into a massive physical obstacle.
The preferred basis problem.
Right. If you're listening to this, you might be thinking, okay, if there are no feelings involved, just take all the microscopic facts, add them together, and you get a macroscopic fact.
But the architecture of quantum mechanics absolutely forbids that kind of simple addition.
It outright rejects it. The microscopic relative facts established between individual particles do not share the same mathematical structure as the macroscopic facts of everyday reality.
Adlam uses a highly specific example from physicist Kaslav Bruckner involving two entangled qubits to demonstrate how structurally alien the microworld is.
Okay, let's rigorously break down Bruckner's qubits, because this is where we see the true conceptual cost of relativity.
Right. Imagine an isolated, entangled state of two qubits, qubit 1 and qubit 2.
Okay, got it.
You can write the mathematical description of this composite state in a specific basis. Let's use the z-axis, so spin up and spin down.
Standard stuff.
Based on this mathematical representation, under RQM rules, you can infer that qubit 1 possesses a relative fact about qubit 2.
Specifically, qubit 1 knows that qubit 2 is either spin up or spin down.
Exactly. However, the Schrödinger equation is linear. It allows us to take that exact same entangled state vector and rewrite it in a completely different basis.
A mathematically incompatible basis.
Right. Let's use the x-axis, spin left and spin right.
Because it's a wave function, multiple valid basis representations exist simultaneously. You're basically just rotating the coordinate system you're using.
Precisely. But here is the profound implication in RQM, in this new rotated basis. You must infer that qubit 1 possesses a completely different relative fact.
Now, qubit 1 knows that qubit 2 is either spin left or spin right.
Therefore, qubit 1 simultaneously possesses relative facts about the value of qubit 2 in two completely incompatible bases.
I want to make sure you, listening, visualize just how bizarre this is. It's an ontological paradox.
It is deeply unintuitive.
It's sort of like looking at a Necker cube, or the famous duck-rabbit optical illusion, but far more severe. The microscopic observer, qubit 1, can see the duck in one plane of logical reality and simultaneously see the rabbit in an entirely orthogonal plane.
It structurally accommodates both incompatible facts at once.
But macroscopic observers, you, me, a Geiger counter, we never experience this. We only ever see the duck or the rabbit.
We never experience a macroscopic object possessing a definite position while simultaneously possessing a definite momentum.
Our macroscopic reality is strictly confined to one preferred basis.
which raises the critical architectural question. How does macroscopic reality pick just one basis?
If a macro observer is nothing more than a combination of micro observers, why doesn't the macro observer inherit this bizarre, multi-basis schizophrenic structure?
Why don't you and I hold mutually incompatible relative facts about the objects in front of us?
This is the core of the structural combination problem. And to solve it, we must look at a universally recognized quantum mechanism.
Decoherence.
Decoherence, the mechanism that constantly strips away the quantum weirdness and forces reality to look classical.
Exactly. But we need to be precise about how it strips it away. Decoherence is not a magical collapse.
Right, it's a completely unitary process.
It's a dynamic process where a quantum system relentlessly interacts with its surrounding environment. Photons scattering off it, air molecules colliding with it.
And through this continuous physical bombardment, the phase relations between the different states in the superposition become entangled with the environment.
And if we trace out the environmental degrees of freedom, the system's density matrix rapidly loses its off-diagonal terms, the interference terms, and approaches a diagonal form.
And it doesn't just diagonalize randomly, right? It diagonalizes in a specific favored basis dictated by the nature of the physical interactions.
That's right. And in our universe, because interactions typically depend on distance, that favored basis is overwhelmingly the coarse-grained position basis.
So the relentless environmental interaction effectively filters out the delicate superpositions, forcing the system into a stable, quasi-classical state.
Decoherence defines the stable structures of our everyday macroscopic experience.
So the natural assumption within RQM would be that decoherence is the obvious built-in solution to the structural combination problem.
It perfectly explains why macro observers only possess relative facts in a single, stable basis.
But this is where Adlam throws a massive mathematical wrench into the works.
A very big wrench.
She points out that you cannot simply rely on a mathematical average of microscopic relative facts and expect decoherence to naturally emerge from that average.
You absolutely cannot. The mathematics are unforgiving here.
Walk us through why averaging fails.
If you propose a solution where you just average out the micro facts, or maybe have the micro observers mathematically vote on what the reality should be,
Yeah.
the resulting macroscopic space of facts inherits the exact same messy, multi-basis structure as the microscopic space.
Because mathematical averaging does not physically trace out the environmental degrees of freedom.
Exactly. Averaging does not induce decoherence.
The quantum weirdness survives the averaging process, which means whatever physical solution we propose to bind microobservers into a macroobserver, the actual mechanics of decoherence must be actively integrated.
It cannot be assumed as a passive byproduct.
Okay, but before we even attempt to engineer that binding process, Adlam warns us of an even more fundamental existential threat borrowed from philosophy.
The subject-summing argument.
In the philosophy of mind, this manifests as the zombie world thought experiment, right?
Yes. The panpsychism zombie world imagines a universe physically identical to ours down to the last atom.
Every fundamental particle possesses its rudimentary microconsciousness.
But when you arrange millions of these microconscious particles into the exact physical structure of a human brain, the resulting human has absolutely no macroscopic inner experience.
The lights are not on. They walk, they talk, they argue about quantum mechanics, but they are a philosophical zombie.
And the fact that this scenario is logically conceivable implies a severe limitation. Merely placing microconscious entities in close physical proximity does not logically necessitate the spontaneous generation of a unified macro-consciousness.
And Adlam forcefully adapts this into the RQM zombie world.
Yes, she does. We can mathematically model a universe where trillions of microparticles are relentlessly interacting, constantly entangling.
Buzzing with billions of microscopic relative facts.
But they never snap together. They never synthesize into a unified macroscopic vantage point.
Just an infinitely dense cloud of isolated private particle facts.
The conceivability of the RQM zombie world proves that just throwing particles into a thermodynamic pile does not automatically spawn a new, higher-level observer.
Which means we are forced to admit that we lack a specific, rigorous physical criterion for when and how a macroscopic observer is created.
We cannot take the existence of the macro world for granted.
So how do we solve this? Let's look at the most obvious, perhaps naive approach. Why not just adopt a universalist framework?
Universalism.
Why not just declare that every arbitrary collection of particles in the universe automatically constitutes an observer?
Well, Adlam completely dismantles the universalist approach.
I mean, if I mentally draw a circle around 3 carbon atoms in my coffee cup, 1 iron atom in my blood, and 2 frozen water molecules on the rings of Saturn.
Does that bizarre, disconnected collection constitute a distinct macro observer?
Yeah, does it?
No, primarily because it is functionally absurd within the constraints of physics. Those distinct particles cannot perform any joint coordinated physical measurement.
They can't collectively interact with the system to physically establish a shared relative fact.
Right, but the practical impossibility isn't even the deepest flaw. The deeper flaw is that universalism triggers an absolute ontological nightmare.
Known in Mariology as the problem of the many.
Exactly. The problem of the many.
Okay, let's explore this because it is deeply unsettling. If you are listening to this, you almost certainly define yourself as one distinct, singular entity. You are one macro observer.
But if the universalist approach to RQM is true, that intuitive sense of singularity is mathematically false.
It's demonstrably false. The problem arises because there is no perfectly sharp fundamental boundary defining which particles strictly belong to the macroscopic system you call you.
Consider the outer layer of your epidermis.
Right, are the dead skin cells currently flaking off your arm part of your observer system?
What about the oxygen molecules currently diffusing across your alveolar membranes?
Under universalism, any subset of particles is an observer.
Therefore, there is a macro observer made of your precise bodily mass plus one specific dead skin cell.
And simultaneously, there is another distinct macro observer made of your bodily mass minus that exact cell.
Which means there isn't just one you.
Occupying the exact physical space of your body, right now there are literally millions of slightly different, massively overlapping macroscopic observers.
And because these overlapping aggregates are technically distinct physical systems, under the rules of orthodox RQM, they are entirely isolated from one another.
Oh, no.
They can, and mathematically will, possess entirely different relative facts about the universe.
This is where it completely falls apart. One version of you, let's call it observer A, might interact with a system and establish a fact that a particle is spin up.
But another version of you, observer B, which is just observer A minus one stray carbon atom, might establish a relative fact that the exact same particle is spin down.
You have millions of overlapping observers in the same physical space experiencing mutually contradictory realities.
And if you are familiar with quantum foundations, that scenario sounds suspiciously identical to the Everett many worlds interpretation.
Where all possible outcomes of a measurement are physically realized by different non-interacting branches of the observer.
But Carlo Rovelli formulated relational quantum mechanics specifically to provide a single-world, local alternative to the bloated ontology of the Everettian multiverse.
If the universalist approach causes RQM to spontaneously degenerate into a multiverse of overlapping observers occupying the same body, the whole framework has defeated its own founding purpose.
It's an ontological disaster. It completely undermines the theory.
So we're backed into a corner. We clearly cannot let just any random grouping of particles be an observer.
We desperately need a specific, mathematically rigorous mechanism to force these micro-observers to combine properly and exclusively.
And to find this mechanism, Adlam guides us through a veritable graveyard of proposed solutions.
She imports 4 major conceptual solutions from the panpsychism literature and aggressively stress tests them against the mathematics of RQM.
And spoiler alert for everyone listening, the first 3 are going to fail spectacularly. Let's walk through the graveyard. What is solution 1?
Solution 1 is known as the identity solution.
Okay.
This framework proposes a radical simplification. It argues that the relative facts of a macroscopic observer are literally identical to the relative facts of one single specific microscopic observer located somewhere within your physical structure.
I have to admit, when I first read this, I laughed at the sheer existential dread it induces.
It's pretty wild.
Let me get this straight. You are proposing that my entire macroscopic reality is dictated by the relative facts established by one specific magical carbon atom.
Somewhere in your left ventricle, maybe?
Yeah.
Or your prefrontal cortex, that is the logical conclusion of the strict identity solution.
But that is physically absurd. What happens when natural cellular respiration occurs and I exhale that specific carbon atom?
Right. Does your consciousness suddenly transfer to a different atom?
Does the exhaled atom float into the atmosphere, carrying my unified perception of reality with it? It relies on a magical, floating locus of identity that has zero basis in physics.
It is entirely arbitrary and physically ungrounded. However, there is a second, far more sophisticated variant of the identity solution.
Called combinatorial infusion or quantum holism.
Yes. This view is heavily debated in the literature. It argues that when individual particles interact and become entangled, they do not merely share a joint state.
They literally fuse together.
Exactly. They cease to exist as independent constituent entities and merge into one single, indivisible, holistic macro system.
Under this view, the highly entangled macroscopic brain is the singular observer.
Now that actually sounds elegant, doesn't it?
It does. We know entanglement creates non-separable states. Why doesn't quantum holism solve our problem? If entanglement binds them, doesn't that neatly give us our single macro observer?
It appears elegant until you realize it destroys the fundamental engine that makes relational quantum mechanics work.
Oh, right, the
So
relations.
remember the foundational axiom in RQM, relative facts only exist between interacting, distinct physical systems.
If you invoke combinatorial infusion and state that entanglement literally merges systems into a single holistic blob.
There are no longer any distinct subsystems left to interact with one another. RQM absolutely requires separation and distinction to generate facts.
Right. If system X and system Y fuse into system XY, they can no longer observe each other.
Exactly. And the problem scales catastrophically.
How so?
Because of billions of years of continuous thermodynamic interactions, virtually every particle on Earth is
This is already entangled.
Exactly. It's already slightly entangled with every other particle.
Wow. So if entanglement inevitably causes physical infusion, then the entire planet and potentially the entire visible universe has already merged into one single massive observer.
And a theory called relational quantum mechanics cannot function if there is only one giant observer in the entire universe.
There's nothing left outside the observer to relate to. The relations cease to exist and reality vanishes.
So the identity solution is physically arbitrary, and combinatorial infusion destroys the theory.
Let's move to solution 2, autonomy.
The autonomy solution takes the exact opposite approach. Instead of trying to merge the macro and the micro, it proposes that macroscopic relative facts are completely autonomous.
Strictly separate from microscopic relative facts.
They inhabit entirely different ontological levels. The facts of the micro world do not combine to dictate the facts of the macro world.
Now, if I'm playing devil's advocate, this seems absolutely perfect for orthodox RQM.
It does.
The defining feature of orthodox RQM is that all observers are totally hermetically isolated. So declaring that the macro world is isolated from the micro world fits perfectly right.
It perfectly satisfies the requirement for isolation, yes. But in doing so, it violently violates the central mandate we discussed at the very beginning.
Think about the implications. If macroscopic relative facts are totally independent of the microscopic world, then microscopic physics no longer explains macro reality.
Macro observers are suddenly elevated to ontologically fundamental entities.
They're magically special systems whose reality is independent of the constituent atoms they are made of.
We have just walked in a massive circle and reinvented the Copenhagen measurement problem.
We are back to saying humans and macro detectors obey special rules that don't apply to electrons.
Precisely. And the philosophical implications of autonomy are even more severe than the physics violations.
If the micro world doesn't actually dictate or combine to form the macro world's facts, why are we even postulating a microscopic world at all?
Basic scientific principles of ontological economy. Occam's razor would demand that we just throw away the electrons and quarks.
Because they are explanatorily redundant.
And once you discard the micro world, you slide rapidly into pure, unadulterated solipsism. Only my autonomous macroscopic experience exists.
It is an absolute dead end for a theory of physics. So autonomy is buried in the graveyard. We can't merge them, and we can't keep them completely separate.
What about solution 3? Strong emergence.
Strong emergence suggests a middle ground based on complexity.
Right, you have your standard microscopic relative facts behaving according to unitary quantum mechanics.
But there are brand new contingent fundamental laws of nature that remain dormant until a system reaches a certain critical threshold of complexity or mass.
Once that threshold is crossed, these new laws magically bridge the gap and spawn distinct macroscopic relative facts.
It's like reaching a certain level in a video game and suddenly unlocking a completely new physics engine.
That is a very apt comparison. Now we have to evaluate this against our two flavors of RQM.
Let's start with orthodox RQM.
For orthodox RQM, strong emergence is instantly and mathematically blocked.
Because in strong emergence, the newly emergent macroentity is ontologically distinct from the microentities.
Yes. But orthodox RQM explicitly forbids distinct observers from sharing any systematic connections or dependencies.
You physically cannot have a fundamental law connecting the microstate to the macrostate because the existence of that law would constitute an absolute non-relative fact.
Right. Orthodox RQM's absolute insistence on isolation shoots itself in the foot once again. It cannot accommodate emergence.
Now, if we look at the upgraded version RQM combined with cross-perspective links,
Where limited information sharing is permitted.
strong emergence is mathematically possible there, isn't it?
It is. You could theoretically write a set of contingent, highly complex laws that map specific configurations of microfacts to specific macrofacts.
You could even purposefully build the mechanics of decoherence directly into those new laws to solve the structural combination problem.
You could build a bespoke equation that guarantees a stable, classical macro world
But Adlam forcefully argues that we shouldn't do this. Why?
because it feels intellectually and computationally lazy.
I mean, if you have to invent completely arbitrary, magical new laws of nature just to ensure that human beings exist and see a stable world, you have lost all the mathematical elegance of RQM.
The entire goal of a fundamental physical theory is that the macroscopic world emerges naturally and inevitably from the microscopic dynamics.
Without needing bespoke human-generating equations awkwardly stapled to the side of the theory.
Exactly. Strong emergence technically works for RQM plus CPL, but it utterly destroys the explanatory motivation for the theory.
Which brings us to a critical juncture in Adlam's analysis. We have surveyed the carnage.
The identity solution destroys the relational engine.
Autonomy leads to solipsism and violates the central mandate.
Strong emergence is a theoretical cop-out.
We are pushed entirely into a corner. We need a solution that builds the macro directly from the micro, actively respects and integrates decoherence, and allows for a shared, stable reality.
And this is the inflection point. This is where orthodox RQM officially mathematically dies, and the upgraded RQM plus CPL takes the crown.
Because we have reached the fourth and final option, the only viable path forward.
The combinatorial solution.
The combinatorial solution proposes exactly what we intuitively desire. Microscopic relative facts collectively constitute macroscopic relative facts.
The macro world is entirely and rigorously built out of the micro world.
But as we established earlier when discussing decoherence, it cannot be achieved through simple mathematical averaging.
No, averaging doesn't work.
Right.
And let's drive the final nail into the coffin of orthodox RQM right now. Why is orthodox RQM fundamentally incapable of using the combinatorial solution?
It comes down to the dimension of time, doesn't it?
It does,
Yeah.
because in orthodox RQM, all observers are utterly hermetically isolated. They cannot share information.
And because they cannot share information, you cannot utilize any dynamic, diachronic physical process, a process occurring over time to combine them.
You cannot use the mechanism of decoherence, because decoherence is fundamentally a physical process of information interacting, entangling, and spreading through an environment over time.
If micro-observers are physically isolated from each other's facts, they cannot participate in a shared dynamic process.
So if orthodox RQM cannot use a process over time, what is it left with?
It is left with a mathematical absurdity that Adlam calls synchronic voting.
Yes, synchronic voting. It requires that at one frozen, instantaneous moment in time, the billions of isolated microobservers in your body just mathematically vote on what the macroscopic reality should be.
Without any physical mechanism connecting them.
Exactly.
It's worse than a blindfold jury. You have 12 jurors in a room, they're blindfolded, they wear noise-canceling headphones, they are physically prevented from ever communicating.
And yet they are expected to spontaneously reach a unanimous, structurally flawless verdict on a highly complex case.
It simply does not work. Synchronic voting does not naturally produce the effects of decoherence.
It provides no mechanism for explaining why the bizarre, multi-basis quantum structures disappear. It is a completely, catastrophically inadequate mechanism.
Which is precisely why the introduction of the cross-perspective links postulate is not just a minor mathematical tweak.
It is the absolute savior of the entire theory.
Because RQM plus CPL physically allows information to be shared between distinct observers when they interact, we are finally permitted to use dynamic physical processes unfolding over time.
And here, Adlam executes a brilliant theoretical maneuver. She adapts an idea from the panpsychist David Chalmers.
Chalmers proposed a fundamental co-consciousness relation to bind microminds together. Right?
Yes, and Adlam proposes its rigorous physical equivalent for quantum mechanics, informational bonding.
Okay, let's unpack informational bonding meticulously, because this is the winning formula. This is how reality is built. How does this bond physically operate?
It relies directly, step by step, on the CPL postulate. Let's trace the mechanics. Imagine observer X and observer Y interact,
Like we discussed earlier, they form an entangled state in a specific Schmidt basis.
establishing a definite relative fact between them. Now, a third system, observer W, comes along.
And W dynamically interacts with observer X in that exact same mathematical basis.
According to the rules of CPL, observer W now definitively learns the relative fact that X held about Y.
The crucial outcome is that X and W now share a relative fact.
They have dynamically matched their relational data.
Exactly. And Adlam's central proposal is that the moment this physical sharing occurs via CPL, an informational bonding relation is physically formed between them.
This bond is not abstract. It physically constitutes a new composite higher-level observer.
But here is the most critical paradigm-shifting part of the proposal. This new composite macro-observer possesses only the specific relative fact that X and W actively share.
Oh, okay, here's where it gets really interesting. This is the decoherence filter.
This explains why we don't see the duck and the rabbit at the same time.
Precisely. Let's trace the physical logic of this filter. Why does the composite observer only inherit the shared fact?
Because microscopic observer X might possess some completely bizarre, mathematically incompatible quantum fact about Y in a different rotated basis.
They spin left-right instead of spin up-down.
But because of the chaotic nature of the environment, it is incredibly statistically unlikely that observer W will accidentally interact with X in that exact weird, incompatible basis.
Right, because of decoherence. The environmental interactions are constantly forcing the interactions into the stable basis.
Yes. Decoherence ensures that as physical systems aggregate and get larger, and as they constantly bombard each other, they are almost exclusively interacting and sharing information in the highly stable, favored basis.
Which is overwhelmingly the coarse-grained position basis.
Let me visualize this for you listening. Millions of particles in the neural networks of my brain are constantly bumping into each other.
Constantly utilizing CPL to share relative facts.
But because of the relentless filter of environmental decoherence, they are overwhelmingly only successfully sharing facts in the stable position basis.
Any bizarre, incompatible quantum facts, the fragile superpositions are not shared.
And because the rule of informational bonding states that the composite observer only possesses shared facts, those bizarre quantum facts simply do not enter the bond.
They are mechanically filtered out of the macroscopic reality.
It is an incredibly elegant, mathematically sound, information-losing feature.
By the time you scale up the architecture to a macroscopic sentient being,
A human constructed from billions of stacked informational bonding relations.
the resulting composite observer possesses only the highly stable, massively redundant, decohered facts.
It perfectly structurally solves the combination problem. The weird quantum geometry is stripped away simply because weird information is statistically too fragile to share across billions of nodes.
That is absolutely brilliant. The physical loss of microscopic information is exactly what creates the stable classical world.
But wait, if I follow the relentless logic of informational bonding, if the act of sharing information via physical interaction creates a larger composite observer,
Yes.
doesn't that logic scale up past the boundary of the human epidermis?
Oh, it absolutely does.
If an entire crowd of 50,000 people in a soccer stadium all simultaneously witness a goal being scored, and they all share that exact relative fact via the photons hitting their retinas,
Do they mathematically and physically fuse into a giant single composite observer?
yeah, do they?
This raises a profound philosophical question, and it is the ultimate mind-bending twist of Adlam's paper. The rigorous mathematical answer is yes, they absolutely do.
That is staggering.
Because remember, the strict definition we established earlier, an observer in RQM does not mean a conscious biological entity with a unified psychological ego.
An observer is strictly defined as a locus of shared relative facts.
Therefore, if a crowd successfully shares a massive set of relative facts, that crowd is a macroscopic composite observer possessing those facts.
So the observer isn't confined to biology at all.
It scales to epistemic networks. Consider the global scientific community.
The entire methodological enterprise of science is built on the rigorous sharing of data.
Publishing experimental papers and confirming relative facts across distinct laboratories.
In the mathematical framework of RQM plus CPL with informational bonding, an entire epistemic community thousands of physicists around the globe sharing the exact same verified data about an electron's mass, is technically, physically, a single macroscopic observer.
And as Adlam points out, this isn't some awkward bug in the theory that needs to be patched. It's the main feature.
RQM plus CPL was designed specifically to rescue the practice of science, to allow researchers to agree on empirical facts.
So the theory enthusiastically embraces the bizarre idea that the scientific community physically operates as a single planetary scale perceptual node in the universe.
But wait, doesn't this bring back our old nightmare, the problem of the many?
Ah, yes.
If the crowd is an observer, and I am an observer inside the crowd, and my brain is an observer inside me, we have recursive layers of millions of observers everywhere.
We are drowning in a fractal hierarchy of observers.
Which is exactly why Adlam leads us to the final, necessary, and perhaps most difficult philosophical conclusion of the entire paper.
Eliminativism.
Eliminativism, the conceptual erasure of the observer entirely.
Exactly. We have spent this entire rigorous deep dive trying to figure out the exact physical mechanics of how to build a macro observer.
And Adlam's final devastating conclusion is that the very categorical concept of a macro observer is a linguistic and psychological illusion.
It is an empty placeholder. We shouldn't be obsessing over drawing boundaries and counting how many distinct observers exist in a human body or in a football stadium.
Because the bounded entity itself doesn't matter, only the flow of information matters.
Precisely. Once you realize that an observer is nothing more than a temporary shifting network of shared facts, you must stop trying to treat them as fundamental ontological objects.
They are not solid bricks in the wall of reality.
All that actually exists in the fundamental rock-bottom architecture of the universe are the continuous distributions of relative facts.
You, as a human being, do not exist as a magical, indivisible, absolute entity.
You are simply a highly dense, incredibly stable topographical map of shared information.
The concept of the observer is eliminated, leaving only the pure mathematical relations.
Wow. Okay, let's synthesize this unbelievable architectural journey for you, the listener.
We started with a fundamental paradox in quantum physics. How does a universe constructed of isolated, private, microscopic quantum facts manage to build the shared, classical, stable reality that we inhabit?
We saw that the original formulation, orthodox RQM, traps us in completely isolated bubbles where a unified reality is mathematically impossible.
It forces us into absurdities like synchronic voting, or it forces us to invent ad hoc laws of strong emergence that violate the theory's own central mandate.
But by rigorously upgrading the theory, by allowing physical systems to share information through the precise mechanism of cross-perspective links, we unlock the power of dynamic informational bonds.
Exactly. Trillions of tiny microscopic physical handshakes are constantly occurring.
And because of the relentless dynamic filter of environmental decoherence, only the stable, compatible, position-based information successfully propagates through these bonds.
The bizarre, contradictory quantum weirdness, the multi-basis duck and rabbit reality, is simply left behind in the dark, unshared, and uncombined.
And the result, this massive, highly filtered, endlessly complex network of shared information, is the solid reality you're experiencing right now.
In this radically relational view, you are not a singular magical entity sitting inside your skull. You are not a panpsychist soul.
You are just a highly stable, billions of nodes deep physical network of shared relative facts.
It is a profoundly relational view of existence. You exist entirely and only in how your constituent microscopic parts inform one another, and how your aggregate whole dynamically informs your environment.
Which leaves you with a final, incredibly provocative thought to ponder as you go about your day.
If macro observers are genuinely just networks of shared relative facts, and if the physical act of sharing information rigorously creates larger composite observers,
consider what happens when you open a history book.
Or consider what happens when you log onto the internet, actively absorbing and verifying data shared by millions of other nodes across the globe.
Are you simply an isolated individual learning a few interesting facts?
Or are you, at a fundamental quantum mechanical level, actively dissolving the informational boundaries of your physical system and mathematically merging into a much vaster planetary scale observer?
The mathematics strongly suggest that you are physically part of something much larger.
Something to think about the next time you send an email or read a new physics paper. We want to thank you for joining us on this incredibly dense, deeply fascinating deep dive into the true relational architecture of reality. We will see you next time.